Okay, my friends, it appears that we have a new mini moon is the claim, and it is an asteroid, and it's just come within the last day or so, and it is supposedly out there. You can't really see it unless you have a telescope, but it is a small asteroid, and it's supposed to be orbiting and then taking off after, I don't know, 2 months, something like that. Now, they have pictures of it. I've seen it, and I think I know exactly what it is, and I will show you right now. The point of this presentation is to show that the things that are in space came from somewhere. Where did they come from? How were they created? And why are they floating around like this? And what is this? And why are these little craters here? Are they just impacts? Well, no, they're not. They're biology, and so is this. You see these straps and these little holes? You see them up here too, the same thing? This is what holds organs into bodies. They have this lock that latches it into the body so it can float around. These are tubes that enter and exit from some type of an organ, and I believe this is a kidney, although I'm not sure. But it's definitely an organ. Now, I'm going to show you other ones that there's literally no question whatsoever what they are. And they have sampled one of them and brought it back to Earth. Let's examine that one. That's Asteroid Bennu. Okay, so we all know what meteorites are. They come down and they turn into iron when they smelt coming through space. They cook up, you see, and they end up being iron. This is cut and etched with acid, and the different types of metals that are in here show in different crystallization patterns. That's why you see different colors and all that stuff. Now, so it's an iron meteorite. Well, that's not a big deal, but this is right over here. That's artery, red, and that's a vein, black. They don't get any redder than that. Now, why is that red stuff, which is blood, doing inside of an iron meteorite? Well, there was probably, it looks to me like this was probably a liver, which is a lot of heavy metal blood, but not a lot of holes. When you get into lungs, like this meteorite, you got all these holes. That's a lung, and it has a spur lock on it. I will show in the microscope. There's no question it's a lung, and there's no question that it's magnetic. It's iron, and you don't get iron until you smelt something at about 2,700 degrees. It starts to turn into iron, and then about 3,000, you get some pretty good iron. But when you get the higher temperatures you get, the better the iron is, because the cheaper stuff burns off. Now, I have another little bitty one here too. That's also a little iron meteorite. And then I have one in the microscope right now. That's this is a bony meteorite. You see that black? You see that? That's magnetic, because that's the blood that boiled out of a bone. That's a bone. You can't do that on Earth. You can't make that bone stay bony and make the blood turn into iron. I think it's impossible. But this is what happens when it comes through space, because the blood literally boiled out of here and burnt up and turned into iron. The bone didn't have enough time to really cook. It just blackened up a little bit. And again, we'll see these in the microscope. That has no magnetic to it at all. It's just bone. But when you come down to where the blood was, which was where the marrow was here, and you'll be able to see that the blood blew out. All right, so let's get started with the microscope, the details, and again, just think about what you're seeing here. There's blood inside, and all of these things I'm showing you are actually body parts, and this is what they found up on Bennu. This is not fake CGI, any of that stuff. They went up there, and they landed right there. Bam, and they came up and they took a chunk of this stuff up with them. This is the colors and the texture of the stuff that they found around this cavity that they went into, and they sunk way down into it. They didn't expect this. It's all particulates in there. because I'm going to tell you what it is. It's biology, and it was blood cells. So why is Asteroid Bennu so important to this whole scenario here? Well, Asteroid Bennu is virtually identical to asteroid Psyche. It's almost completely made of metals, but they're not smelted. They're metal atoms. This is smelted metal. Okay, smelted metal means that it's been cooked off and turned into iron primarily and metals, as I showed you before with the when it was cut across. Now, I believe these are hearts. And I do understand hearts extremely well. I have studied many of them. And what happens is the plumbing right up here that attaches to the bulb, this thing actually twists. And this whole goopy stuff up here, this real goopy looking stuff, glues all that into the heart. The heart can move around and do all this jiggling around, but the tubes are pretty well stationary, and the glue holds it in. Well, when it dries out, it just falls off, and you end up with this, or that. And the plumbing from here, and you have these, the valves. It's as simple as that. That's glued on, literally glued on. When the glue dries, it goes. And here's where the glue was. We're going to look at this very closely. This is almost undeniable. I asked about phosphates in membranes, which I know they're saturated with, and they're made out of phospholipids. Yes, phosphates abundant in cellular membranes, primarily as part of the phospholipid membranes. The phospholipids make up the lipid bilayer membrane, contain these phosphate groups to help create this separation of the head of hydrophilic and hydrophobic tails of forget all that stuff. You don't have to know. The key is they didn't expect to find phosphates, and phosphates are saturated in membranes. And guess what they brought back? All right, you don't have to know anything whatsoever about chemistry or biology or anything. All you have to do is look. This picture and this picture are the same picture. Well, why is all this white stuff here? Well, here's what they're going to say. This is a phosphate surprise. That's because these are phosphates. Analysis of Bennu's sample unveiled intriguing insight into the asteroid's composition. Now, this is really cool, but you got to think. Dominated by clay. Clay, that's flesh. He took 100 pounds of clay. Now, dominated by clay minerals, particularly serpentine, which is muscle. The sample mirrors the type of rock found at mid-ocean ridges on Earth, where material from the mantle, the layer beneath Earth's crust, encounters water. Well, forget about that part. This interaction doesn't just result in clay formation, it also gives rise to a variety of minerals like carbonates, iron oxides, which are blood, iron sulfides, which come from blood. But the most unexpected discovery is the presence of water-soluble phosphates. These compounds are components of biochemistry. They're from membranes. And they're from all known life on Earth today. Now look at this carefully. Think about this. Don't jump to conclusions. We're looking at two different pictures. What is the difference? The white. Well, what is the white? It's a surface layer of membrane. That's membrane. Phosphates. All right? That surface layer is phosphates. Water-soluble phosphates. They're in your body. That's a membrane. Now, what else can we see from this? Where do you see this? All right, I'm just going to rack it up. All right, what do I mean by that? Well, I'm going to show you so much stuff that you cannot dismiss what I'm showing you. This is the samples from Bennu. Don't forget now, this is the phosphate layer, which is a membrane that coated, you have membranes all over your body. There'll be a coated membrane here, another layer. See, that's membrane, membrane, membrane. What are these little blocks? Let's follow this through very, very carefully. That is the phosphate layer, which is the membrane. All right. Now, looking at it without that specific type of light, you don't see the membrane now. You just see like a rock. Now you got a little piece of it over here. What does that look like? Well, here it is here. A little bit smaller. And here it is here. And there's that membrane layer right underneath it. I mean, that's just, the white stuff is membrane-ish. Phosphates. Now look at this. That's this really highlighted. Boy, that's interesting looking blocks. With all these little stripes in between them. Block. What would cause something like that? Stop and think about that for a minute, because I know exactly what caused it. And you will too. Okay, my friends, this is going to be fun. There's no question whatsoever what this is. It's a heart. That's a heart, which these are down to the valves, as I talked about before, and these are the valves. And that's Psyche, and that's Bennu, and they're made basically of blood and muscle. That's what they look like until you take off the tubing. And then you get down in here, and almost all of that is blood. You've got some layers of tissue, but not much. Even those are completely saturated with blood, because those are the muscles. So you have almost nothing but blood in these hearts. Virtually 100%. This is not deniable. You cannot deny this. This is 100% certain. That is heart muscle, and these are the phosphate layers, which are membranes that surround the top and bottom of them. They have to be able to move, but they have to be able to slide amongst each other. Muscles pull in, but they also twist and move and slide back and forth. And in between there is what's called the fluids, I can't think of it. Synovial joint fluids. Well, I call them Slurpees, small leucine-rich proteins. And then they're in there and everything can slide. Everything's fine. So that's your layer. Now, can I prove that? Absolutely. That's what it is. These are muscle sarcomeres, the same thing. They have those little blocks, identical to what you saw. And this is from heart injury. This is heart sarcomeres. And they're broken here, you see? And you see the layers in between there? Those are the phosphates. So these can pull in, but they can also slide among themselves. These blocks pull in like that. And this got torn. Now, why? I don't know. The guy's got an injury to his heart, or he's dead. I'm sure he's probably dead. They didn't see that without doing an autopsy. But this is... That's what we're seeing coming back from Bennu, is heart muscles. You know, the phosphate surprise, come on, it's just, you can't miss this. A tiny fraction of Bennu sample returned by NASA, shown in microscopic images. Top left shows a dark Bennu particle about 1 millimeter long with an outside crust of bright phosphates. An outside crust. That's a membrane, is an outside crust of bright phosphate, which is what membranes are made of. The other three panels show progressively zoomed in views until you get right down into the muscle sarcomeres. All right, let's finish up on Bennu, and then I'm going to show you a bunch of other body parts. That is Bennu, and right there, this part here is the tendon. Tendons are tough. The rest of the goop just ripped off and left us with the ventricle valves, the valves. And here they are here again. Same thing on Psyche. But that one got too close to the sun or something and cooked it up. Because they had to go to at least 3,000 degrees somewhere around there to get that kind of smelting. And I showed you what smelting is, I'm pretty sure, and all it is cooking something in space or in a furnace. So that's that. Now, this is Bennu, and it's back here on Earth now. Well, not this whole thing, but they landed in here and they pulled out, I don't know where they hit it, but it doesn't matter. This whole thing is a heart. That's a tube coming out. That's not an impact, this is a tube. These different colors indicate different blood, the different oxidation states of red blood. Halfway out, not red, and then black is completely vein. And these are vein and artery valves, and these are the tubes coming out. I have a closer shot of that. Look. That's a tube. That's a tube. And you see these colors? And these are not impact craters all over the place. This is so saturated with blood, it's unbelievable. And these pop. Those are popped out. Those are not impacts. And that is also a tube coming out. This is just nothing but a big ball of blood, not just pumping blood, but there's so much blood around everything because the muscle requires just literally tons of blood. All right, so let's get into the biology. This goopy stuff is literally glue. The heart is just continuously doing all this, and that is the glue that keeps it from ripping out of your body. And these are the tubes that run from the valves. When this dries up or separates, you end up with the chambers down here in a ball, which is what we have. All right, and then you have a bunch of little plumbing coming out here and there. But all these little dots, those little dots are not impact craters necessarily. There may be some, but most of these are explosions outwards from cooking the liquid blood. That's what's happened. They blew out. And why? This is because this is what's wrapped around your heart. They cook. The surface is completely saturated, the outside surface of your heart. There's a layer around the outside, which is the membrane, but underneath that, this is all 100% blood. And they explode in the heat of space, because space is not, let's say space is cold. I don't care. But where the sun hits things, it burns it like hell, just like this up I'm going to show you on Comet 67P. Right there is cooking in space. The gases are not just blowing off there in the wind. We're going to be talking about that in a minute. But I think Bennu, I've gone over pretty well. And again, this is, well, you can see right here, you see those? That's the tendon that locks it in and attaches to the muscle, and it twists. And that's what it is. It's a heart. So I've shown you the sarcomeres. I've shown you the valves. I've shown you the plumbing. I've shown you the blood vessels. I've shown you, biology of sarcomeres. There's nothing hidden here. Is what it is what it is. And this is what the membranes are all around everywhere, and they're phospholipids. There's 2 layers of phosphorus, and that's what makes the phosphates they couldn't understand. You can see them separating the muscle. Very, very simple. All right, I know you're not going to be able to see this unless you have Mudfossil eyes. This right here, I believe, is this area right here, where all that plumbing comes in here. And I can see different colors in here of different tubing that's coming in, and I will show you in the microscope. All right, so that's where all the plumbing comes in for this. Basically, it's like this or something like that. And it was laying flat on its back like that, so it's flat as a pancake. Now, there is another hole here, which looks like it ate through being laying flat like this. It sort of drained out of that hole, I believe. But that, I know for a fact, that circle there is, I think it's this. I think this is exactly what it is a kidney. And that's what's coming around, heading towards Earth right now, the 2024 comet or asteroid. All right, here's something to look at. This is 2024 again. And this is not an impact. I don't think. It could be. But this is certainly not. This is part of the strap mechanism that locks it in to the body cavity or wherever. Those are little straps, and those little round things are normally enthesis balls. Now, of course, this thing's pretty big. I think it's 1,800 meters or something like that across. So you can see the straps. Now well, hold on. Give me 1 second. Okay, something to consider is that every organ in your body has to be locked in its position. It can't just go flying here and there and floating around. So it has an attachment. It has a latch, a lock. And here's what they look like. All right, this body part, whatever it is, I don't know what it is. It could be an organ, it could be a muscle, it could be a tendon attachment, but it has an anchor spot that anchors it to the next body part that it has to attach to. This is an injury. I almost get all my information from injuries because they look down and say, wow, look at that, it ripped away. That's not supposed to rip away. Now this is a rock that I have here. This is this rock right here. And that is basically meat. Well, it was meat one time. And this is the fascia. This little latch right here is something that medicine doesn't even know about right now. That latch, I call it the spur lock. There's two little dots here down at the bottom to transfer the fluids from whatever this organ was into the next organ through these little latches. And they all have them. Like this here is a human DNA tested lung from the Great Flood, same as my other stuff, flat as a pancake on one side, because it died in the flood. All of the bodies were boiled during this event where we were almost hit by Venus. Now that right there is the latch at the bottom. That's the lock that locked it in place. And there was another one up here. You see that little circle up at the top? So this could sort of move around a little bit, but it's not going to go floating like sideways and that type of thing. And this is extremely heavy, dense pleura. And I have a ton of lungs. I have them like this, I have them completely stripped, and I have another one that has half of the pleura and half of the stuff is missing. Right down to the alveoli. I have literally, if I don't have it, there ain't any of it. Let's just go with that. All right, once again, I call that the spur lock, and that locks these breasts into this chicken. And what does it do? All of these little fibers run out, and they wrap around and hold that breast. And this, all organs and body parts and muscles have that latch. Just like this, has all that white stuff going out, and then it flares out and gets thinner and thinner, but there's sheets surrounding. That's the membrane. All right, this is the lung I showed you right here. And again, very flat. They all died in the Great Flood. And this is just raw blood coming out of here. This was DNA tested. I drilled inside of it and got blood from deep inside, not from the surface. However, you could scratch that and just get raw blood off of there. That's literally saturated with blood. This one here leaked blood out of it. This is what came out of that one. These little bubbles of blood came out from these little red spots. You see it? And this is a lung. There's no question about it. You see these little alveoli here? The round little circles? You see them? That's what they are right there. That's what a lung is. It has alveoli in there. Now, this is what they call pleura. Completely gone from there. Totally gone, and it's down here. The pleura surrounds the lung, which is primarily a membrane. Now, remember I told you I have one that's halfway in between? Here it is right here. This is another one, flat as a pancake in the back because of the Great Flood. All right, now, what is this? That's the pleura here. It's pushed over to this side, and this side has just the lung. And we're going to go through all of this stuff in a microscope, but this is going to take a while to do. You see, remember the spur lock right there? They all have that little triangle right there on them. Even the ones that are so, look at this. This, I don't know what it is. It's some kind of, I don't know what it is, but it was a lung, and that's where the plumbing came in, and that's where the spur lock is. They all have it. They all have that little latch. And that's totally different material than the rest of the lung. It's a completely different substance. And I have it on this one here, which is a meteorite. That's a lung. This coming through space, the blood explodes out. That's why you see all these little holes. And I can show that in a microscope. You're going to see them exploding out. They didn't just leak out. They boiled and went But it wasn't hot enough because it's just not heavy enough to completely smelt into solid iron, like a ball of liquid iron. It still has its structure. This one has more structure. It's smaller. It depends on how big and heavy it is how much it's going to cook up. And then I had this, which is a bone. And that's bone. Again, we'll be seeing this in a microscope. And that is the blood, this is the marrow. And that boiled all up, and that is magnetic because it's turned into iron. This is not magnetic because it's just bone. That's magnetic because it's turned into iron. You see? The blood will turn into iron because it's almost, well, your blood is almost all iron. There's a ton of other stuff in it, but there's so much iron that's why it smelts coming through space. So lungs, hearts, livers, all good candidates for iron meteorites. And then you have all kinds of different types of meteorites that are not from those parts. They're from other body parts. And they know they're all kind of strange ones because they could come from your finger, and there is. Well, there's one Oumuamua out there is a finger. I'm not kidding you. This is, everybody thinks this is a joke. Not a joke. That's a finger. You see that? That right there is the bend in the finger. Let me show you something. Bones anchor. Like right there. All right, so this is the fingertip headed this way. That's the grip skin. That means that's the real dense skin on your finger. It's peeled away. That little round spot right there is the anchor at the tip of the finger. You see that? Take your time. Look at this white strip coming down here and coming down here, and all these little dots. And this seam right here. That seam, all these little dots, all those little dots are just like the thing I just showed you. All these, it's just like this. All these little dots are down here. The green that was something else I was playing around with, so don't worry about the green. That wouldn't be in a bone. This would be just white. But all these things anchor right there so that it can be pulled. And this is a different type of bone, but if it had the seam as this one did, right on the other side, you have another tendon coming down. So your finger can do this. This is the actual joint right there. That's that right there. This is the grip skin right here, peeling off the finger. Right at the very tip, it's called an apical tuft. And I got one here somewhere. Here it is, right? That's what's at the tip of your fingertip. I'm not kidding you. And all of those little balls lock all of these tendons in. There's a ton of little tendons. And that's one ball that's still stuck. And that's what's at the tip of your fingertip, and that makes it so that you can pull your finger up and down like this, so using those tendons. I got anything there is, I got it. If you want it, I got it. All right, so there's your top of your finger, and then it splits here, and it goes down here. Down here, you see the black? And you see the white over here? That's your vein in your artery. And these two over here are the tendons that run right over the top of that knuckle. That's your knuckle right there. This is the whole fingertip right here, all the way back, and it's ripped right off of the knuckle. All right, and that's where the tendons keep going down. That's these here. Oumuamua is a fingertip. And all of this, I've had books. I had anatomists look at all this stuff. They don't want to be mentioned who they are, but they agree 100%. I never had one of them say I was wrong about any of this stuff. 100%, straight across the board. Because they know these are autopsy guys. Like this, Comet 67P. You think that's just floating around in space? It just ended up being that way? That is a hip joint. Oh, come on, Roger. Well, let's take a look and see if I can make that statement stick. What is a hip joint? Well, that's a hip joint right there. And it's broken. in a similar place, although it's further out, I think. But these are the type of fractures you get with these sockets like that. It's right there. Now, well, first of all, well, let me show you the details. All right, this is just no question what's going on here. You see that giant plume coming out of there? That is literally barbecue gases, and they did sample it, and they say, I got the spectral analysis. This goes back to 2015. Now, these, you see all these little ones going up here? And then going out the side? The sun's hitting in a different way now. So it's not hitting down into the artery. It's hitting into the little blood vessels that feed up into the muscle, which would have been attached here, or whatever it was attached to. But you feed little bits through these little bit ones, but you have to have a main feeder, and that's the artery. Now, you see these little latches here? That's how this whole thing was held in place, it appears to me. But you notice this is not gassing off. There's no blood in there. You don't need blood in your tendon. In the end, there is no blood. The blood feeds the muscles and so forth. Okay, I'm sure you remember that big jet of smoke coming out like a shot coming out of the side of 67P, and then the other one, there's little bitty things. Look at the size of this. This is 40 meters. There's 4 approximately in there. All right? That's 160 meters. That's approximately 500 feet. 500 feet across there. They call these dragon balls. I'm not kidding you. These are little blood vessels. And this is what was cooking. When the sun hits it just right, but it's got to be close enough to the sun where it's being irradiated strongly enough so that it can blow out into space. And that's why at only a certain time they get close enough and they're just coming the right way, and the sun is hitting them and they're coming at it, and then it goes away. So they always thought it was solar wind. It's not. This is cooking. The astronauts say space smells like steak. Chanel, I think, actually made a perfume called Eau de Space or something like that. See, this is the chemistry 67P. They took 2 samples up there and they analyzed them. And it's all hydrocarbons, silicon, sodium, carbon, hydrogen, and then you get into your irons. All right, ferrous oxides. This is what blood is. It's almost all blood. So these are the samples they took, and they said, yes, this is all organic chemistry. So have a nice day. All right, here's what we got in space. This part here goes in there. This is part of the thigh bone. So we got this ball coming down with this neck down to this bone. And I believe it's broken off right down in here somewhere, way down here. And there's some tendon left there. We'll see a ball of tendon somewhere, whether it's this or what, But it could be a human, it could be anything. I have no idea, but it's some kind of creature's body. Looks very similar to this. It's in this vein. All right, so this is stripped of everything, and it's fractured somewhere up, a little further up, I think. I'm not sure. But here's what it looks like here. So the ball is there, the neck comes down, and wherever the fracture is up in here, and again, I don't know if this is human or if it's, the hindquarters of a giant creature. I have no idea. Horse? Who knows? But I can tell you one thing for a fact, that there's almost no question whatsoever. That is shooting out, and they know that this was the chemistry, is shooting out organic juices, and space smells like steak. And that's the rest of the blood vessels spewing out their gases as well as they cook. Sounded very, right out in space, when you're in space and you get whacked with all those sun rays, you cook. This brings up actually a very interesting point. They say the speed of light is just consistent and never changes. Well, it depends how close you are to the sun, whether or not this is going to cook. And I think it also depends on which direction you go, if you're going towards the sun or away from the sun. Away from the sun, I don't think it'll cook. Going towards the sun, I think it will amplify the light and cook up. And I would like to know, this was February 3rd, 2015. This was January 31st. So it's been between 5 days of this event. Was it heading towards the sun, or was it coming away from the sun? I say going towards the sun. All right, these are actually little straps. They're little straps, and they run up and attach, and then you have an area here will have a bundle. And I believe this is exactly what we're looking at right here on Comet 67P. These are the straps, and that right there is a little bundle of tendon. I believe these are also tendons, but they go off to another direction. You see the bundle? And these are the straps. Now, why do they break off right here? Because that's where they were attached, either to a bone or to another, to a muscle. And they have what they call, well, I call them abrupt transitions, and they just break off in these spots. And this just broke off where it was. Now, I don't know how this gigantic thing got in space. That's all speculation. But what is here is here. It's already been analyzed. It's already been tested. Some of the stuff that's out there on Bennu is back here on Earth right now. It's already been, I've shown you, there's no question what it was. Here it is right here. It's sarcomeres, membranes, which is the phosphates. They never expected any of this. All right, and then here's what they are. There's the sarcomeres right there. This is blood sarcomeres. I mean, heart sarcomeres, and that's an injury, but it's not quite obvious the same stuff. So, once again, I've proven my point. It's just so much detail, it can't be denied. Now, I'm going to do the microscope stuff, but this took a lot longer than I had suspected. But I do have the meteorite here that I'm going to show you. There's still blood in here, and that blood still has catalase reaction. Catalase is in every single thing that was ever alive, plants, animals, everything. It scavenges oxygen. If you put hydrogen peroxide on, which is H2O2, instead of H2O. H2O is water. H2O2 is water plus an extra oxygen. You don't want that extra oxygen. So catalase says, oh, whoa, there's extra oxygen, and it bubbles it off. So if there's blood in here and membranes, they will still have catalase in them if it stays in a good state. And coming through the space, most of them didn't stay too well. But I think I got a catalase reaction out of that one, and I think out of the little one. These are identical. You see that? They're basically identical. Yeah, they're identical. And they both have the spur locks on them. But I don't know, creatures have the same kind of biology. That cooked up, and that's all these little boiled off little holes. Same thing here, boiled off. And I have other ones that were here from Earth. That's a lung, and that just everything eroded out of it, and it just left all of the integrity, the fabric of the lung there, but everything else just eroded out. There's still a lot of red blood in there. You can see really, you can see it easily. But this one, the spur lock was right here, which is the latch, and it just snapped right off. It stayed with the other piece. That happens both ways. It can come with itself here, away from the other one. In other words, this would have been attached like that, only the spur lock would have been laying right on top of this angle here. And it snapped off, and the lock went with this piece, and this went on its own. So it happens both ways, but that latch is tough. That thing holds in tight. And I looked at it very carefully. It's a circle like this, and there's all kinds of gnarly looking fibers coming into it, angled fibers, into that circle, and they're all over the place, and they anchor things together. That's how you're held together in your body.